Hey everyone, this lecture is powered by Study Studio channel and presented by me, Saiankit. This is about me. I am Saiankit and I got a 99.24 percentile in JEE Main 2019 with a CRL 8757. I got a score of 321 in BITSAT 2019 and CRL 1755 in MCIT. I stay in Hyderabad and I'm waiting to be an undergrad. Welcome to the second lecture of modern physics. Coming to today's class plan, we will be discussing the concept of electronic emission. This is a very important topic in the view of JEE, BITSAT, and NEET. Each year we encounter problems on this topic, mainly the photoelectric effect, which we'll be discussing in further classes. A keen understanding of today's topic can easily yield you marks and boost your score. I'll also be discussing with you some questions which will help you understand this topic even better. A detailed problem-solving session on this topic, mainly the photoelectric effect, is awaiting in upcoming lectures. So, why we learn electron emission? In the early atomic theories, we were having this notion that atom is indivisible, Dalton's atomic theory. But the discovery of electron by J.J. Thomson unleashed the new spectrum to study and reinvent new atomic theories involving the subatomic particles. People who were developing new atomic theories were in constant research. Parallelly, another branch of people arose asking that why atom emit electrons? Because electrons are inside the atom, but how and why electron emission occurred, and there was research going upon it, and we will be traversing through them. Let us get an idea how electron is emitted from the atom. Electrons in the outermost orbit are most loosely bound. Since they are at maximum distance from the nucleus of the atom, the force of attraction by the nucleus on the outermost electron is very less as compared to the force of attraction by the nucleus on the innermost electrons. In case of metals, electrons can move freely inside the metal surface but cannot come outside. Why? Because when outermost electron tries to exit the atom, the atomic surface instantaneously acquires positive charge and pulls the electron back to the surface. This instantaneous positive charge is also caused to the nucleus of the atom. Nevertheless, the outermost electron is loosely bound. It is not in the stage of exit from the atom. The nucleus guards its own electron from losing. Then how come electron come out of the atom? For the electron to come out of the atom, some work has to be done by the external force. This external force is referred to as work function. The minimum energy required to liberate the most loosely bound surface electron from the metal without giving it any velocity is called as work function. It is denoted by the letter phi. Work function depends on properties of metal and nature of its surface. The energy for electron emission is provided by different sources, and they are thermionic emission. If the energy is provided by changing temperature and transfer of heat, which results in the emission of electron from a metal, then the electron emission in that case is referred to as thermionic emission. Field emission. If the energy is provided by changing electric field, then it is referred to as field emission. Photoelectric emission. If the energy for the electron emission is provided by the light particles, also known as photons, is known as photoelectric emission. Photoelectric effect. The phenomenon of emission of electrons from a metal surface when exposed to electromagnetic radiation of sufficient frequency is referred to as photoelectric effect. The electrons eject from a metal surface when the metal is irradiated with radiation of sufficient frequency. The effect of emission of electrons when the light or the electromagnetic radiation is irradiated is referred to as photoelectric effect. In the coming up classes, we will be discussing Hertz observations and its relation to photoelectric effect, Lennard's photoelectric experiment, terms of photoelectric effect, Einstein's explanation towards the photoelectric effect, and the laws of photoelectric effect. You can find us on social media through our Facebook page, Instagram handle, and you can mail us at studystudio.saiankit@gmail.com for any queries. Thank you for watching. Please like, share, and subscribe to Study Studio to boost your BITSAT or JEE score. Also, don't forget to turn on the notification bell.